Hello friends, I am Valliyammal from Department of Computer Science SF, Assistant Professor, the Standard Fireworks Rajaratnam College for Women, Sivagasi. In this video, I am going to discuss about the topic Normalization in DBMS. Let's move on the session. So this is the learning outcomes of normalization. First to see about the introduction, then to understand the functional dependency, and third one is the types of normal forms, and fourth one is process of normalization, and finally to see about the merits and demerits of normalization. Let's see about one by one. First one, what is normalization? So the normalization concept was introduced by database pioneer E.F. Codd as a foundation for relational database design. There are three features of normalization. First, to see the normal forms. So normal forms are the set of progressive rules for relational schemas that reduce redundancy and prevent data anomalies. First one is the organizing data. So organizing data is a systematic process of structuring data in a database to reduce the redundancy and improve integrity. The second one is reduce redundancy. So it eliminates duplicates, data storage, and the piece of information to remove only once, stored only once. And third one is ensures integrity. It maintains data accuracy and consistency across the entire database system. So before going to normalization concept, first to understand the functional dependency. So functional dependency occurs when one attribute uniquely determines another attribute within a relation. It describes how attributes in a table relate to each other. So if attribute A functionally determines attribute B. So we write this as A determines B. Then to see about the types of normal forms. There are 5 types of normal forms in normalizations. This is the 1NF, 2NF, 3NF, 4NF and 5NF. In this video, we are discussing about the topic 3 normal forms, 1NF, 2NF and 3NF. First, to see about the first normal form. So first normal form, eliminating duplicate records. A table is in 1NF, it satisfies the many conditions. That means first one, all columns contains atomic values. Second one, each row is unique, that is no duplicate rows. Each column has a unique name. Then the order in which the data is stored does not matter. For example, this is a phone number. So if a table, this is an example of 1NF, if a table has a column phone numbers that stores multiple phone numbers in a single cell, it violates 1NF. To bring it into 1NF, you need to separate phone numbers into individual rows. Next one, second normal form. Second normal form, eliminating partial dependency. That means a relation is in 2NF if it is satisfy the condition of 1NF. So it has a no partial dependencies. A non-key attribute should not depend on part of a composite key. Example, it is the problem of department name depends on department ID not on student ID. Let's see about the example. So there is the key student ID and course ID. If the student name depends only on student ID, not on the entire key, it violates 2NF. To normalize, move student name into separate table where it is depends only on student ID. Next one, third normal form. Third normal form, eliminating transitive dependency. A relation is in 3NF if it is satisfied 2NF and 1NF. It has no transitive dependencies. So non-key attribute should not depend on another non-key attributes. It's a problem. Department name depends on department ID. This is the example. So it's considered a table, student ID, department ID. So student ID depends on student name, and department ID it depends on department name. So this is the normalization process in 3NF. So the first table to unnormalized table, that means student ID, name, course and instructor. Then it converted into 1NF, that it removes repeating groups, ensures atomic values. Then apply to 2NF, that it removes partial dependencies. Then finally it's moved to apply 3NF, it removes transitive dependencies. This is the normalization process. Finally, to see about the merits and demerits of normalization. First, to see about the advantages. First one, eliminates redundancy. So minimize the repetitive data, saving storage space and avoiding errors in data updates or deletion. Second one, reduces storage requirements. So organizing data into smaller table, storage is used more efficiently, reducing the overhead for large databases. Third one is improves consistency. So it prevents data anomalies by ensuring each piece of data is stored in one place, reducing inconsistencies. Then next one, enhance query performance. So simplifies the queries by breaking large tables into smaller, more manageable ones, leading to faster data retrieval. And final one, prevents anomalies. So prevents issues like insertion, deletion or modification anomalies that can arise from redundant data. So next is about the disadvantages. So it creates a many tables and requires complex joins, then and it may slow and read operations. Thank you friends. I hope you enjoy this video. Then we will meet the next video.